This material is made available to you by or on behalf of the University of Melbourne under Section 113P of the Copyright Act 1968. It may be subject to copyright. For more information, visit the University Copyright website.
Well, good afternoon, everybody. Those of you who are here today, I hope this is going to be an interesting hour for you. What I'm going to do is go through a series of case studies with a view to trying to show you the breadth of projects that you might come across that you need to do a risk assessment process as part of doing the project. Whether you're the project manager or a project engineer or an analyst, you could very well come across projects such as these. I was one of those lucky people who was able to work on a whole variety of projects over my career, and each of these projects I've had experience with similar sorts of projects, so it makes for an interesting career. So these are the case studies that I'm going to go through. There's a tunnelling one, a flooding one, an odour complaint project, or dealing with odours in a process plant, a toll road issue, a bicycle rider being hit by car doors, and a train derailment for a tourist railway. So you can see it's quite a variety of projects that risk assessment is applicable to. So what I'm going to just go through briefly each of those projects so you can get a feel for the sort of projects that may arise and the sort of risks that you need to assess, looking at the hazards and then the risks and then the mitigation measures from that. So the first one deals with tunnelling and particularly dealing with unstable ground, meaning ground that could collapse whilst the tunnelling is underway. Not collapsing when the tunnel is finished, but collapsing whilst the tunnel is being excavated. That's one of the riskiest times when you're doing your tunnelling work. So the first thing is a qualitative risk assessment. We'll go through, look at the hazards that are there, and then look at the potential risks of the tunnel failure from a whole lot of different causes, different hazards and different causes, including unstable ground would be one of those hazards, that you're tunnelling through ground that could be unstable. And then the tunnel design and construction team have got to be involved in looking at those hazards and the risks that come from it. Just for interest, this is a tunnel has been excavated at a short distance, and here they are spraying concrete onto the roof of the tunnel, the back of the tunnel, to support it temporarily whilst they move forward again. And it's those situations that where the hazards are and when the risks arise. A lot of tunnels these days are excavated using tunnel boring machines, and if you don't know what they are or what they look like, here's one sitting in a shaft ready to start tunnelling into here, and they consist of a cutting head which rotates and it pushes forward with these grippers here pushing against the side of the wall to stabilise the machine whilst it pushes forward. And there are cutters on the head of this cutting out small pieces of rock, and those small pieces of rock get taken out on a conveyor system through the centre of this. And there's then behind this cutting head, there's a framework here where you can put up steel or concrete support, usually called a temporary support, whilst the tunnelling is going forward. And once the machine's disappeared, then you come back and put in permanent concrete and so on. That's what you see when you see the finished tunnel. So failure events for tunnels using tunnel boring machines have been analysed over many, many tunnels to identify the sort of risks that come from the typical hazards that you get whilst you're tunnelling. And here's an example, 57 cases that have been documented, and they've been divided up into groups or major factors that these failures occurred in, and they're all been defined excepting for 4, which were perhaps a whole lot of different ones which couldn't be grouped together. So launching the shield is the first one, which is where you're doing this, you're just starting the machine off, pushing it into the tunnel. Next one is the other end, where you're pulling it out of the tunnel and you're starting to lift it out up a shaft. You can see there's been less incidents there. Interfaces between stable and unstable soils, that's when you're tunneling along in one sort of ground condition and all of a sudden it changes and you get into a different ground condition and you've got to change your methods of tunnelling. And so you can see when that occurs, there's quite often high-risk incidents or occurrences of failures due to those risks. The next situation is where you've got a mixed face of both rock, hard material and some granular soil. In other words, a mixture of material that you're working through all of the time. And look at that, you've got, out of these 57 incidents, you've got 15 that have happened in those sort of circumstances. So obviously that's that particular hazard is a high-risk hazard. The next one, look, 13 as well, the high-risk head access for maintenance. What we're talking about there, sorry, went the wrong way, is at some stage the cutters on the front of that rotating head start to wear. And somebody's got to go in there and change those cutters, put in new ones so that you can still get the same productivity. So what has to happen is that cutting head has to be pulled back a bit from the tunnel face and people have to go in front, unscrew, unbolt those big cutters and replace them. Pretty hazardous situation, and you can see there's been plenty of accidents or incidents occur when that's happening. Then there's got the mechanical failures where somebody's been doing some repair work on the machine somewhere and there's been some accident or issues arisen, and then these others. So you can see that's a way of trying to get some data, analytical data, to assess the risks. But for unstable ground, the best way to get a handle on that is to look at the ground itself. So you go and do a lot of drilling. These are drill cores taken from a coring machine that's drilled into the rock ahead of where you're going to be tunnelling. So you can try and pick up, is there a mixture of rock? Is there a change going to occur? And so that's done with a whole bunch of data that you've collected from these drill cores, and it's then analysed or compared with other tunnels to see whether it's a high risk or a low risk by giving it a number. And that helps you identify the risk and the location of any potential unstable ground. And so the number, you don't need to know all about this, but they're geotechnical people. If there are any of you in the group here who are particularly interested in the geotechnical stuff, you come up with this rock mass rating or a quality number, which is based on a series of parameters that you can obtain from those cores. And so you come up with a rock mass rating, which is anything between 0 and 100. And if it's up at the 100 end, it means that the rock's strong, good, no problem. If it's down around the 0 end, then you've got soft ground, difficult ground to support. So that gives you something to base some judgments on. But in getting all of that material, you've got to do a lot of drilling, takes a lot of time, and it absorbs a lot of money. And so the project owner will say, do we really need to do all this drilling? Do we have to wait and do all this to be able for you to assess what the risk is that the tunnel is going to give us some problems? And it's an age-old problem. And when you're as a project manager or a project engineer, whoever's controlling the money will be asking you those questions. Do you really need to spend this money to do this, to assess the risk? And you've got to make a judgment call, because if anything happens, you'll be responsible. If you said, I think I can work from the few samples I've got, and I can tell you that there's no problem with the ground, or there won't be any problem until we get 100 metres in, or whatever it is. So here it is. You could be asked to evaluate the investigation data, recommend how much is required, and provide an opinion on the frequency and severity of the unstable ground, and give an opinion. So it's a risk assessment. You've identified the qualitative aspects of it, but you really need to get into this quantitative stuff, look at how much data you've got, look at the variability of it, and say it's too variable, I need more data, or it's okay, I'll go with what I've got. So you can see that there's a need for moving from the qualitative assessment into the quantitative assessment, which you're going to be talking about after Easter. It's an essential link when you get into this sort of risk analysis.